Hi everyone, I'm Yun Su. Thanks for inviting me to participate in the Best Research Award. I received my PhD from Donghua University in 2018. Now, I'm an associate professional at the College of Fashion and Design, Donghua University. My research interests include development of smart and protective clothing, and numerical simulation of heat and moisture transfer in clothing materials. In recent years, I gained Shanghai Xiaoning Plan for Young Science and Technology Talents, Shanghai Zhenguang Talent Plan, and excellent doctoral dissertation. Also, I'm a guest editor of Sustainability Journal. I published more than 16 research articles and book chapters in international journals, and 20 papers in international conference proceedings and presentation. In addition, I presided over 10 scientific research projects, including the National Science and Technology Convention, the Ministry of Education, the Shanghai Municipal Science and Technology Commission, and the Education Commission, and participate in the design of special clothing for astronomers. The National Key Research and Development Plan and the National Natural Science Foundation. In research years, I have carried out close cooperation with scientific research institutions and relevant enterprise at home and abroad, and many achieved the following 3 presentation research results. Firstly, we have built an extremely environment simulation experimental platform for thermal radiation, thermal conduct, high temperature, steam, hot steam, low temperature, and other extreme conditions. Also, we proposed a standardized test method for the protective performance of textile and clothing, and selected it as the lead article of the International Journal of Thermal Science magazine. We realized the promotion and application in the product testing of enterprise, such as Nanjing Fiber and State Grid of China. Secondly, we have built a multi-heat transfer and multi-phase flow dynamic model of textile materials in extreme environments. We put forward an innovative research and development model of multifunctional protective clothing, and submarine rescue, anti-immersion clothing, and other functional clothing. We have revealed the role of human thermophysiological response in extreme environment, and realized human safety risk and reasonable risk prediction. We also want to provide a theoretical basis for the functional identification of clothing products of benchmark enterprise, such as Boston and Anta Clothing Company. Now I want to present an important research job in this conference. The title of the presentation is Numerical Simulation of Heat Transfer in Electrically Heated Footwear in a Severely Cold Environment. The work was published in Building and Environment of International Journal. And the purpose of this study was to investigate the mechanism of heat transfer and thermal regulation of electrical heating pad in footwear. Through numerical simulation, below the allergy for the clothing or smart clothing is very important. A lot of allergy is waste of in social society. We want to develop a good control categories to reduce the allergy and look for a best method to control heating pad. So in this work, we develop a one-dimensional heat transfer model based on parameters of footwear materials, heating pad, and skin tissues. The model was validated by a small-scale fabric experiments. We used two models of temperature control for the heating pad and human skin. And we also compared these two modes of temperature control. Also, a parameters analysis was controlled based on this developed model. The results show that the model prediction were in agreement with the experimental results in a severely cold environment. Generally, the human skin modes had better thermoregulative performance and less energy consumption than the heating pad model. Results from the parameters analysis demonstrated that the properties of the heating pad and the inner fabric layer were the most important factors for affecting the thermoregulative performance of the electrical heated footwear. No scientific changes were found in the thermoregulative performance, but the environmental temperature had a clean influence on the allergy safety effect. Besides, the energy efficiency could be remarkably improved by lowering the heating power even in a severely cold temperature of below 13 centigrade. The common lithium battery was able to function the heating pad temperature control model of the typical 4-layer fabric system for 7.7 hours. The research provides suggestions for the design of kitchen part as well as the upper of the electrical heated football, and can help people control a good or a comfort temperature. It can save a lot of energy. So this is my recent research work. That's all. Thanks everyone.